This is iTaxon. iTaxon is an example of a semantic media wiki. So it's a wiki in that you can edit it. It has version control, so you can see all the past edits. But unlike normal wikis, the underlying information is very structured. And what you can do with a wiki like this is link together all sorts of information and display it in the same place without actually having to type that information in. As an example, the page you're seeing here is for a publication called The Amphibian Tree of Life. And on this page we can see a list of authors of this paper, the journal it was published in, various identifiers for that publication, some GenBank sequences that have been published in that paper. We can also see a map of localities mentioned in that publication, and down the bottom we see some facts about this publication. These facts are shown in RDF, and Semantic Media Wiki can extract these facts and display them. Here we see the date, various identifiers for the publication, the authors represented using FOFMaker, and some identifiers for the publication. What makes Semantic Media Wiki different is that all this information you're seeing on this page has been constructed by a database. It hasn't actually been manually typed in. To show you what I mean, if you want to see the code for this page, just like in a normal wiki, you can go and view the source. We're just going to edit this page over here. And this is all the information that's actually been typed in to this page. It's basically just the name of the paper, a list of the authors, the year it's published, the journal, and some identifiers, and that's it. So the question you might have is, well, where does all this other information come from? Where do the sequences come from? Where does the map come from? And so on. This information comes from links between this publication and those bits of information. So for example, if we go and have a look at the map, I'm going to click on this point over here. This is a GenBank sequence, accession number DQ283378. If we go and have a look at that, I click on that and we're going to go to the wiki page for that sequence. Here's the wiki page for that sequence, and as you can see we have a map and down the bottom some facts about that sequence. If we zoom in and have a look, we can see that at the top of this list of facts is the DOI for a paper. In this case it's the DOI for the publication on the Amphibian Tree of Life. So this links this sequence to that paper. It's saying the sequence is published in that paper. You can also see down the bottom that we have some geographical coordinates. We know the latitude and longitude of the sample that sequence was taken from. So that gives us a map of where that sequence comes from. The sequence is taken from a frog called Nimnonictes poilani, and that's there in the wiki page, and if we click on that and zoom out, this is the wiki page for that animal, and it lists the sequence that we've just been looking at and displays a map for where this frog is found. And again, in this case, all that information is derived from the sequence. Again, if we look at the underlying source code for this page, this is what's actually been typed in, and you can see it's just basic information about the genus, the species name, the authority, and so on. We haven't put in information about the sequence. The database underlying the wiki has done that for us, and it's done it by using this taxon identifier here. This is the NCBI, the GenBank taxonomy identifier. That makes the link to the sequence, and as a result, when the wiki displays this page, it collects all the sequences for that taxon, and if they have some geographical information, we get a map. So for each one of these pages that we've been looking at, the actual information on each page is very limited. It's just about the object you're looking at, but the links are then gathered together and they add extra information to that page. These extra links are put there by the use of templates, and templates is basically where you can write queries that tell the wiki, if I'm looking at a publication, please list on that page all the sequences that were published in that publication. In other words, all sequences that mention, for example, that identifier. We can also investigate some links between other aspects of the publication. This very large paper on the amphibian tree of life has a whole bunch of authors. If we click on those authors, we can see information about them. So here's the page for the author Darrell Frost, and in this wiki at the moment there are 2 papers that Darrell Frost has authored. The amphibian tree of life that we've been looking at, and another paper on frog family, the Hylidae. And again, on this particular page, there's actually the information we've had to type in is very minimal. If we go and have a look at the source in this wiki page, it's purely there's a person with a last name Frost and a first name of Darrell. And again, there are the 2 publications. If we go and have a look at the other paper that he's been involved in, we can see much the same thing. Here's a wiki page for this revision of the Hylidae. There are the authors, the journal, and again we can see some sequences that have been linked to this publication. We have a map, and in this case we also have the abstract. So the key thing that the Semantic Media Wiki software that underlies iTaxon enables us to do is we can put in very minimal information about these objects, for example papers, taxa, sequences, and people, and by exploiting the links we can generate these quite rich pages which include, for example, information on geography without actually ever having to directly type that in for the actual page for the paper. So this is iTaxon.org. You can see this demo at iTaxon.org wikidev. It's live, it's very experimental and is likely to change, but I hope it gives you some sense of the potential of semantic wikis